All right, everybody, moving to 7.3's last section here before our quiz. Again, so our quiz is going to be 7.1 to 7.3. All right, now the big thing here is we're going to be talking about finding special products of polynomials, but the big thing that I want to make sure that I get across before we start is that this is no different than what we have been doing. We're still multiplying, we're still distributing, we're still thinking mass distribution, all right? But there's just some unique cases that we could run into that we want to highlight. All right. So if you remember, all right, these you will not have to memorize, right? But these are the by book definitions of those unique cases that we could run into. Now we won't have A and B. There will be numbers in place of A and B. But basically what this is saying is, if you remember in 7.2, we left off with that last example of the square, right? What would we do if we saw the squared? Because the plus and the minus sign is in here, that means that we are not allowed to distribute that square like that. That's illegal. All right, we talked about that with rules of exponents. So what this square is telling us is that we're going to write the parenthesis twice, and then we're going to distribute. And this last one down here, all right, is really illustrating that if we have the same thing in both parentheses, all right, and the signs are just opposite, that means we're actually only going to get two terms as our final answer. That's really what that's illustrating. All right, so here we go. Those are the special cases that we could run into. And if you remember, last class I said on the homework, there's going to be this term there called FOIL, right? Use the FOIL method. Now, the FOIL method is exactly what we've been doing. We're distributing. But what it's saying is that if you had a binomial times a binomial, the way we would multiply is FOIL is an acronym for the process. Again, it's only 2 by 2. A 2 by 2, all right, is when we would use this term FOIL. We'd multiply the first terms in both parentheses, the outer term in both parentheses, then we'd multiply to the inner terms, and then we'd multiply to the last term. And then really what that is example, right? We have a binomial times a binomial. Only time FOIL works, right? We multiply the first terms, then we multiply the outside terms, then we multiply the inner terms, and then we multiply both last terms, all right? So that's what that term FOIL means. Again, some of you are sitting there saying, well, that's exactly what we've been doing. Yep, exactly what we've been doing, just a fancy term, all right, for what we were doing. So here we go. Let's look at an example, right? So now we see that square pops up. So now we know this square. Do not distribute this because there's the plus sign in here. If this was all multiplication, we can. No distributing of the square. The square is telling us to write the parenthesis twice. And then we're going to multiply just like we normally would. All right? Regardless if you just use distributing or you want to be fancy and refer to it as FOIL. All right? We're going to multiply everything out. This is what we would get when we multiply it. The 3p times 3p is 9p squared. 3p times 9p is 27p. 9 times 3p is 27p plus 81. Now remember, and I noticed on some of your, on majority of your homework assignments, all right, you need to have these steps written. You cannot go from this to the final answer. I want to see these steps, and some of you also, I want to make sure that you fully simplify. Don't forget, multiply, simplify. We can combine like terms here. The p's will go together, and we should get what's here as our final answer. All right, 9p squared plus 54p plus 81. All right, again, remember, write it twice. If you see the squared, write it twice. We cannot distribute. Here it is again, right? We see the square. That means write it twice. Then we can multiply it out. All right, when we multiply it out, we should get what's here. The 6 times 6 is 36. 6 times negative p is negative 6p. Negative p times 6 is negative 6p. Negative p times negative p is p squared, positive p squared. All right, we got like terms. Simplify the like terms. And again, make sure we write it in the correct order. This p squared should really be first, and that 36 should really be last. So when we do combine like terms, and we write our final answer, make sure we put that p squared in front. Combine the like terms, and make sure you put that 36 last, and it's a positive 36. All right? And then last but not least, all right? Again, nothing changes in what we're doing. We're going to distribute, right? Those x's have imaginary ones. Don't forget that. So when we multiply, all right, 2x times 2x is 4x squared. 2x times negative 3x is negative 6x. 3 times 2x is positive 6x. And then the 3 times negative 3 is negative 9. Now you'll notice these are like terms in here. However, they cancel. Negative 6, positive 6, right? And then it just leaves us with our final answer of 4x squared minus 9. Now again, this is one of those unique methods because of what we talked about. It's the same thing in both parentheses, but the signs are opposite. So if you ever notice that, again, if you don't notice it, it's not a big deal. All right, you just do what we've normally done. But it's a little trick because if you do notice that, you know, hey, this is going to cancel here in the middle. Should always happen. All right? Again, if you got questions, make sure you reach out. This is a shorter lesson here today. We're in a review mode. Next class, we're going to have a quiz. Peace out, homies.